now we're going to look at simplifying these radicals that have constant bases, or radicands. So when I say constant bases, I'm talking about a problem that has a rational exponent, and this would be the base. It's a constant because there's no variable in it, it's just a number bases. And number bases, or number radicands that when we have a root symbol. So if I'm asking you a question like this, find the real number, key is real number root, if possible. It ties into the rules that we had mentioned in the earlier video. If I look at something like example 1, I know this is a square root, so this is an even number. And so and also the definition. By definition, I'm saying, what number, when squared, do I get negative 81? It's impossible. It's impossible to square a number and end up with a negative when you're dealing in the real number system. Now, we will learn later on in a later video that if we step outside the real numbers to the complex number system, we can do this by defining what square root of negative 1 is, but in that it exists. But we're just staying in the real number roots. If I ever ask you that, square root of negative 81, not possible, so not a real number. And that's all you'd have to say on something like that. You can never have a negative radicand with an even index when you're looking for a real number root. Now, it's okay though if it's odd. So if I have an odd, can I rewrite this so that I have the same exponent, same power as my index for a base, so that I can use my rule of power over index? So this is really negative, let's see, this would be negative 4 to the third power, because it's odd. So negative 4 times negative 4 is positive 16 times negative 4 is negative 64. So this is my whole base, or radicand, all to the third power. Now I can use my rule. This is really negative 4 to the 3 over 3, which is just negative 4. And so odd number index is okay to have a negative radicand inside, and we can solve for that and we'll get a negative answer. So that's the kind of number-based ones that you use. Now, you're not restricted to technology in any of this, and I want to emphasize that. You can use your calculator, and so these number bases or constants, you can, but you want to make sure that you can actually type it in correctly, and it's good to know how to do this by hand, because then you can always check yourself. It's really going to be emphasized in this problem. I'd much rather really see you be able to do this with the calculator, because there's a lot of the exponent rules and different things tied in here, and it can get pretty complicated to do a problem like this by hand, but we'll show you. And then you can always refer back to it, and then I'll show you how to do it with the calculator as well. So on this one now, these kind of questions where we have number bases, it's evaluating rational exponent expressions. And why are we doing these when we're dealing with the radical? When we're in a chapter that's dealing with radicals, and we're simplifying problems with rational exponents, because they're interchangeable. We're going to go back and forth sometimes with the forms. So 121 to the negative 1/2, using my exponent rules, if I was to do this by hand, I would think of this as really over 1. So this now negative exponent rule, reviewing your rules, you send that base down and that exponent becomes positive. So nothing's left on top except for 1. 1 times anything to itself. I'm not flipping the fraction, it's just I'm sending that base down that has that negative exponent to give it a positive exponent. Now once I have 121 to the positive 1/2, I could switch forms if I wanted to. It's power over index. So this is the same thing as saying the square root of, because you don't have to write the 2, you can if you want to, but it's the square root of 121 is the same thing as saying to the 1/2 power. Now you may recognize that, and it's going to be helpful to recognize the perfect square numbers and know what their square roots are. That's 11 times 11. I would say at least up to 12 is really helpful, and you can just give me 1 over 11 for this question, or if you didn't recognize that, you play around with it. This is really 1 over the square root of 11 squared. Now really that's 11 to the 2 over 2, so you'll end up with just 1 over 11, or think of the square and square root kind of wiping each other out. And 1 over 11 would be the answer for that one. So you're going to do problems like this. This is one where it gets really kind of tricky with the, doing it by hand, and so definitely technology is going to help you out. So let's look at this problem. And example number 2, how could I do this by hand? Say I lost my calculator, I forgot it, I'm taking a test or something, and well, the first deal is one of the exponent rules says if you ever have a fraction to a negative exponent, you can combine a couple of exponent rules and say, hey, if I flip this 64 over 27, this becomes a positive exponent. What we're doing is actually using the power to power rule and negative exponent rule to send up and down, but it's just a shortcut of combining a couple rules. So if you ever have a fraction to a negative exponent, you can flip that fraction, keeping everything the same inside, change that to a positive exponent. Now I can do power to power, because like exponents of 1 on this. So I'll end up with 64 to the 2/3 all over 27 to the 2/3. Now that's messy looking, right? I mean, by hand this is kind of a pain, but now I'm actually going to take this and I'm going to switch forms, and I'm going to write it in power over index, 64 squared. This is index of 3. This is the index of 3, and this is 27 squared in here. All right, so now this is what will really help you. You can think of you can actually think of 64 is actually a perfect cube number of 4 cubed. So I could write this as 4 cubed times 4 cubed, or 4 cubed quantity squared. There's 2 of them. The square tells you there's 2 of them. 4 cubed is 4 cubed, or 4 cubed all to the 2nd power. Either way. Maybe I'll even write that way, just to show you originally. Like this is really 4 cubed quantity squared. And this is really 3 cubed quantity squared. I just replaced 64 as 4 times 4 times 4. So I want to look for a base that has that exponent that's the same as my index. So now when I do this, you could even expand this out and do power to power if you wanted to. Or you can think of there's 2 of these 4 cubes. You're going to take a 4 out and then another 4 out, and there's nothing left inside of there. This one you can take a 3 out and another 3 out because you're going to have 2 of them, and there's nothing inside of there, so you're going to end up with 3 times 3, so you'll end up with 16 over 9 as your final answer. Now, that I think is actually trickier than most any problem you'll see in the whole chapter or this whole lesson by doing it by hand, because it's number bases or constant bases. I'm using a lot of our exponent rules. I say if I give you a problem like that and I'm asking you something like that, if you can, know how to, if you can use your technology and you have the access to it, know how to enter that in correctly, and you can actually just give me the answer. I may ask you for the simplified fraction form, so I'm looking for 16 over 9, so know how to do that. So I'm going to show you how to do that with the calculator. So I'll just pull this down, turn this on. So as this is warming up, you'll see on the screen is popping up. One thing we're going to look at is I'm going to show you with the TI 84. That's the calculator I have with me, but you can also do it with the TI 30 X2Ss, and so I'll discuss how you can do that as well and how you'd enter it. I'll just write it on the board how you can enter it in the calculator. But I want to show you on this one, if you have the graphing calculator, a lot of people do. You will, either way, it doesn't matter. You don't have to have it for this class at all. It's just both of them have a little different way of looking at this. But if I'm looking at this calculator, the very first problem we looked at was something like this. We took 121, and I'm going to hit my caret symbol, which is right here, and this calculator means bring it to that exponent. Now this calculator has math type, so it looks like an exponent. It's going to go up in the exponent. You don't actually have to have math type. You can just put caret symbol. If you don't have math type, then use parentheses to include all of this as your exponent. You'd have to close all of it in parentheses. So then I'm going to type in -1 divided by 2. I don't have to put it all in parentheses because it's telling it it's all in the exponent. But otherwise, if I was using the TI 30 X2S, I would use a parenthesis here and a parenthesis here with the caret symbol, and it'll just write it out with that caret and then parentheses, but it's telling it the same thing. So all of that is in the exponent. And then I would hit enter, it's going to give me some crazy decimal, but I'm asking for it in a reduced fraction form. So if I'm asking that for this calculator, I would hit math and then enter on fraction and then enter again, and it'll always give you the reduced fraction form of 1/11. So if you can do that with your calculator, that's great. Now on your other calculator, it's going to actually TI 30x2s or one of the other TIs that's not a graphing calculator with this function. I would actually just hit second F to D. The button's right up on top. You hit second F to D and it'll put fraction to decimal, and then hit enter and it'll give you the reduced fraction form. And then if it ends up being a mixed number, if it ends up being an improper fraction, this calculator will give it to you an improper fraction form. The other ones will give it to you as a mixed number, so then you can just hit second and then the button just below the F to D, and it'll actually translate back to the improper, but you can leave it in the mix, it's fine. So that is how to do that kind of a question. The next question, how do I enter in the fractional one? So I'm going to put a fraction. I'm in a parenthesis, 27 divided by 64, parenthesis, caret symbol, and then I would put parentheses if I was using the other calculator and put -2 divided by 3 in the exponent, and it's going to give me 1.777 repeating, or 1.7 repeating. And so then I'm going to hit math, F to D, and you get 16/9, which is what we should have by hand. Now your TI 30x2s will generally give you this in a mixed number form, so it'll say 1 and 7/9. That's okay, or you can switch it to the improper. So if you know how to do it with calculator, I'm okay with just the number-based ones, constant-based ones. You can use your calculator and just give me the answer on those. We're going to focus more of the work on the variable bases and variable radicands.